Okay. So what we did last time, we'll just touch it up a bit. Last time we did see the water-based systems like a sprinkler system here. Okay, sprinkler system. Then what are the typical differences between sprinkler system and hypermist system? Like these bulbs, different bulbs. How does it operate? What is this? For example, what is this bulb? And then deflector plate. We went through all of it. Then we also did the typical pumps, the fire pumps, fire lines, and a diesel-driven emergency fire pump. Just there are a couple of requirements, and that is how we go about. So also we saw that emergency fire pump is never located in machinery space under any circumstances. And any diesel driven pump and all must start at 0 degrees Celsius. Then it should start so many times because the battery shouldn't drain out if it is a battery starter. And how much fuel we need, at least 15 hours and plus 3 hours. That's 18 hours fuel must be there. 3 hours on the body means the service tank, and 15 hours in can. Now it is in hours, it's not in liters. Then water sprinkler system, these are the wet types, means the pipeline is always under pressure. And this is the typical diagram. I told you that instead of drawing this, you should be able to draw a box diagram, which is showing the functions, because you must know different functions. And especially when we talk about any one of the fire systems, what we need is to have full understanding of various alarms and switches which are there, especially alarms, because when you get an alarm, you take action. If you don't identify alarm, you can't take action. That is exactly what goes wrong. So you have to know what to expect on every equipment. Now, by decreasing size of the water droplet, we do much better job. So we started having the two types of hypermist system, the high pressure one and the super high pressure one. The idea is, just think here, 1 liter of water turns into 1700 liters of vapor. To turn into 1700 liters of vapor, there are two things. One is going to absorb with the latent heat of evaporation, a lot of heat, and it's also going to displace oxygen, which is supporting the burning. Usual stuff will be there because the newer technologies means higher maintenance cost and all, but they are more efficient. That the sizes are smaller and the efficiency is higher. So overall, the technology always wins. And we saw here, say, 1 liter of water with a sprinkler, it covers up about 2 square meters. And hyper mist, that is high pressure water mist, can go all the way up to 6,000 square meters. So that is the efficiency. With the minimum thing, you achieve maximum. Results are the best. So we continue further. Now what happens is, when we realize that water is there, and okay, you can always keep this extra stock, which is not really that bad because ships also produce fresh water. So it is not a big issue. Thing is, if we have got any sort of spray systems, water spray systems, it is going to cool. Why? Because it puts water over the large surface and the heat is absorbed. Now, couple of places where you need this sorts of system is like fluorocar decks, tank decks of gas chemical tankers. Because normally, when we look at dealing with any fire of this sort, like cars, chemicals, Generally, water is a better agent because it removes the heat and the fire will extinguish itself. Now, you have got, now this is okay. The main stop valve and all means basically we are looking at the same thing. Pumps pressurizing the water and release through nozzles with small orifice so that there are sprays. And that spray breaks up into small particles. The water gets into small particles, small tiny bubbles which become microscopic. Now again, everywhere, first thing you'll need uh, some sort of a detection system. Now you will have detection system, but normally hypermesh systems, because there is a lot of pressure involved in it, are managed automatically, not automatically, manually. Rarely you will find any hypermesh system which is automatic. It's practically non-existent. And that means what happens is I get alarm first. I decide to use hypermesh means I open the valve. Moment I open the valve, there is a drop in pressure and the pump starts automatically and starts pressurizing and it reaches the end, and where I open the final valves which are connected to the nozzles and we start spraying water all over. Now on Roro ship, spraying water means you are removing heat, everything all right, but even now when I look at it, it is like washing the car. So it doesn't do any harm. It will not do any harm to unburnt cars or unburnt part of the car. Then you have got fixed pressure ones. Again, this is like tanker pump rooms and all. Basically, idea of this fixed pressure or other ones high pressure system is you use very little water, so the pumping out and all is not a big criteria. You are removing heat. That is the main criteria. Now gas carriers also have spraying system. Now this sprayer system, they have come out even with the container ships on deck. So you should be able to create something like artificial rain on containers so that in case there is any fire, it will douse itself by reduction of heat. So those systems are also already in and they are getting all sorts of approvals for it after we saw some bad fires on container ships. Now here, if you need to keep whole thing cool, crew protection is also, that is the same way we spray it. Liquefied gases in a bulk. It covers up cargo tank domes, exposed parts of cargo tanks. Now, what happens is these cargo tanks, exposed parts, are not exactly something that you can touch because temperatures will be extremely low. Then there is a cladding. There is a cladding means some sort of insulators put, and then it is wrapped. So that is where, in case anything is there, we will be cooling the outer side insulation in case there is any fire inside or to remove the heat, because heat is also another issue by which the tank pressure will keep on going up and liquid will become vapor. These are the areas where there are variety of these sprayer systems. Here, superstructure, deck houses, everything. Here you have got sprayer systems and all facing cargo area. Okay. And before you all get out of the college anyway, we will have some people coming down from gas carriers. That time, just remind me, even though it may not be in this semester, if it is in this semester, very good. If it is not, still okay. But they can probably explain you a lot more on these systems because they have experience. These are very new systems. And then the usual stuff is there. How many liters are required and how much is the flow. Here there is a diagram. Okay, water is flowing when you control the valve. Then once you open it, then it will go further down. Dangerous goods, it is again nowadays what you are looking at it is if it is stored under deck, but most of the time you are carrying it in containers, so you really don't have a systems. And container ships on deck, there are no system. If it is stored inside, we also have a system like CO2, and if we need, we can always use sprayer, water sprays to cool down. See this venture system bank. So many valves are there. You're supplying water, then you open wherever you want to drench. Now you remember, no, when you get drenched in seawater or rainwater. Same thing. So same word, drencher system. Normally, it is not covered much in your syllabus because these are new things and not really compulsory everywhere. You can run ship without this system, so it's still not around. Similarly, you have got passenger ships. If you have got balconies, you have to have some sort of sprayer system in case there is a fire. It just gives you massive shower, or you go under the rain and you become all right. Like you drench yourself so you don't catch fire. Oil tankers may have spray curtains to isolate accommodation. Means in case there is a fire on cargo tanks anywhere on deck, your accommodation is protected by water spray curtain. So it will be spraying water from the top point, and it is like you are on one side of the water spray and the fire is on other side. Now here it is compulsory. Okay, after 2009, if you go on newer ships, you will find it on chemical tankers. Now, water spray system on stores like paint locker is very normal, very, very normal. This is one method where you have got something like a deflector plate is there at the end. You manually open the valve, and so there is a sprinkler, but it doesn't have the bulb. That quartz bulb is not there. That is one system for paint locker. Other one is generally a CO2. But this is more common, more economical also. So this part is finished, which where we discussed about water as extinguishing medium and what systems we have got available. Now, anybody has any doubts? Try to raise hand. No, Danish, what is it? Yes, it is in a form of mist. When we say hyper mist system, it is always in a form of mist. Idea is that whole thing should be like fog. So it absorbs all the heat. Anything more, Danish? Answer? No, very good. No, miss, I must know that you all are listening or you can hear me. Okay, anybody else has got doubt on water-based systems? No, I got no from 1, 2. So I assume we are okay with water-based. Okay. Now let's move to the next part. gaseous system. Now, we are saying first part was using water as a medium. Now we come to the gas. Now, gas, which is normally used on board, is carbon dioxide for extinguishing fire for a variety of reasons. There are more efficient gases, but they are very expensive and technological challenges are required. So, over a period, it will come. For all you know, over a period, you may harness nitrogen. Possible. Already we see that inert gas is being replaced by nitrogen. So similarly, it is possible. But right now, what we are looking at is carbon dioxide. Because inert gas is also there, but it's a mixture of many, and it becomes difficult to compress it and liquefy it. Carbon dioxide is relatively much easier. Now, where it is used, typical machinery spaces, cargo holds, ro-ro spaces, galley exhaust, duct. Okay, this is the duct. Now, what happens is when we say here, halocarbon are one of the halon and all which are not allowed because of greenhouse effect and all. Then there are substitutes, but they work out very expensive because they are rarer gases. Now, when we have got any gas for extinguishing fire, it will have to be delivered through a fixed piping, because how will you take it? In case of water, you connect a hose and take the water and start dousing it with water. But when we talk about gas, the gas has to be taken there by fixed piping and nozzles for delivery, and it has to be stored something like this. Now, this is the typical storage of certain capacity. Now, how we operate will come down to that. Now, when you start network of piping, there will be some regulations on that, which we have covered under FFS. Now, first part, we start. The space, now you are going to protect with CO2. Fine. How much CO2 will you keep on board? So there are rules saying that 40% of the largest compartment and so on. So there are a set of rules. Next is, okay, so much volume is there. Then there are rules and regulations on how the piping should be. What sort of arrangement should be there on piping? How do you start discharging these cylinders? And so on. Where do you keep these cylinders? Are they exposed to accommodation? Like that. There are many rules which we have already studied them under FSS and also under SOLAS. So now we are just revising it. So let's start first. Now, carbon dioxide is not really friendly to human beings. Even though we exhale it, we can live in CO2. So, if you are going to release CO2, in case some life form is there, you are going to kill that life form. So, on life form on board is seafarer. So, there must be audible warning. Wherever you release CO2, that location must get audible warning. Now, it can be variety of things. You have got audible visual warnings in engine room in case you are going to use CO2 there. That alarm is different. It's a separate from emergency alarm. If it is going to be on in a cargo hold or something, then we have got a different way of doing it. Ro-ro ships, you will get alarm. If it is a bulk carrier, you don't have alarm fixed inside, but then there is another method of making sure that nobody is inside. You take head counts. Okay. And it is unique. Now, how much time alarm must sound? Not less than 20 seconds. Why? Because person has to get out of that compartment. When you hear CO2 alarm, You don't think of anything else, just run out of the compartment. That's the only thing you do. Now, for that reason, there are, this is not less than 20 seconds, this might be even more. It means in most of the times it will be at least about 2 minutes, allowing people to escape from engine room. Otherwise, you will kill some people. Now, this is to ensure activation of alarm before release. There are two separate release controls. Now, that is something like a pilot gas cylinder. It is like actuator. When the alarm starts when you open the cabinet door where pilot gas cylinder is fitted. So you open the cabinet door, alarm starts. Then another alarm will be when you operate this, because this is going to operate main bank of CO2 cylinders. So this is the opening control box. First alarm starts. So they can start running out immediately. And of course, these are additional arrangements. Okay. If that alarm starts, it can start closing the, because you can't release CO2 when there is a ventilation going on. Idea is to release CO2 and close all the ventilation so CO2 stays there. And it ensures that fire gets extinguished. Why? Because because it reduces oxygen. But ventilation must be stopped. This is more realistic arrangement. This is how it is. It's a large number. You may have 200 to 50 cylinders, depending on size of the ship, of course. But 200 to 50 cylinders is not abnormal. So they are stored like this in the bank. These are the ones which are securing arrangements, means they don't run out. It's a simple securing arrangement. Something is here, it's tightened from here, so it is sort of, you can say, doesn't allow any movement. It is like held, the way you held with the belts and all, same way. And these all cylinders, the discharge valves are there, which are connected to normally a wire. And then there are other arrangements with the pilot valve. When you open that small cylinder, what we saw earlier, that pressure opens up all these valves. Okay. All valves will get opened up with that pressure. And then a bank will be released. Now there are banks like this. This is considered one bank of cylinders. So this bank may have 40 cylinders. There are 5 banks. So if there are 40 cylinders, there is a calculation done how much CO2 to be released. So based on that, number of banks are discharged. Now automatic release of this gas is not, for CO2 is not permitted, because a false alarm can kill people as well as finish off your gas. That is why CO2 is always manual, because normally you are not going to get permission to put automatic one, not on normal ships. It is like here, machinery space, possibility is there, but normally you are not going to get this permission because of risk involved. They are always stored outside the protected space. Now, protected space is where you are going to discharge. So, suppose I am sitting in a room and it is protected by CO2. I can't have CO2 cylinder in the same room. It has to be outside somewhere. Now, that is what it says. Now, these other gases. Now, just if you remember, it's fine that these are very specialized gases. In this case, there may be a special permission which says you can keep it inside. Earlier days, some of the very specialist dangerous cargoes used to carry some of the specialist gases. for extinguishing that part. Today, unlikely you're going to come across this sort of experience. Now this is another one. See, this size is smaller and all because they are halocarbon. Okay, that is a different gas, halon, and their substitutes. Then there are other systems like this is still normal high pressure system. It becomes a little excessively technical here, but a pressure release valve, because when you are going to handle anything under high pressure and release the gas, it is possible it may exceed the pressure, and this is always on open deck. This is never on inside accommodation or somewhere where it can hurt. It is always in an area where, in case of extra pressure develops, relief valve will release it without hurting anybody, because CO2 is not for us. Now, these pressure switches there are quite few pressure switches, and these pressure switches are there to set off alarm. There are many types of alarms. Another one which is important is there is a connection of airline to the system, so that you use airline and there is isolation process and all to blow piping clear. You blow it clear so that there are no obstacles gathered in that. It may be cargo residue, it may be condensation, and condensation becoming ice, that is also possible. So we always take a lot of care of draining the system and so on. There are a lot of diagrams. You will have to ask either Upinder Singh or Prem Kumar sir. This is more standard arrangement what we look at. Okay. Bank of the cylinders. Pilot gas one will open these valves and release the bank. Then airline connection is there for blowing this pipeline clear. There is an isolation valve. This is kept closed, and when you want to open it, you also isolate this part so that air doesn't go other way around and act on any valves here. So there is a way to do it. Then pressure switch is there to tell you, yes, it is going out. Pressure gauge. These are the manually operated valves. Okay, where you release it according to the wherever you want. Now, this sort of a drawing, without drawing each and every cylinder, you should be able to draw. That is important. Now, since we are here, we will also have a look at, because this drawing is quite good to explain that. I have got, say, 200 bottles of CO2. How do I know that they are not leaked out? 200 bottles are not easy to handle. How do I know they are not leaked out? So what we do is, normally every dry docking, every 5 years and all, we check the weight of the bottles. Or there is a level gauger. This level gauger is sort of ultrasonic device, which you hold it in a hand and take it up like this on the side. When it finds the level of liquid like this, it will give alarm, so he marks it. This point is marked. That is level gauge checking. It's approved. Another one is actually weighing the cylinders. Now the problem comes. How will you actually weigh the cylinders? Are you going to remove 200 and take somewhere? No. We generally have arrangement on top. There is a bar. Okay, there will be a bar there. What we do is we slacken this holding thing so the cylinder can move. These things are disconnected and cylinder is checked with a gauge here, which is attached here, hook is here, and this is connected here. And you check the weight of one, go to the next one, next one, next one. That is another method which is done in dry docking. Now, CO2 room. CO2 room is always outside accommodation. Okay, always. There is nothing like there is a CO2 room inside. No, never inside accommodation. Next, CO2 room has got its own ventilation system. We always leave it on because there is a probability of any gas leaking. This possibility is always there, so we always ventilate the space. CO2 room, if it is locked, key will be available next to the door, but then you will have to break the glass and take it out. When we release CO2, we go like this. There is a calculation how many to be released for what compartment. And it is done in two parts. First part is blasting it off and then you slow down. Now these are more complex things. And this is something, there are rules, but again, it depends on fire and captain will be taking this decision. Isolation valves will be there in the system always because when you're going to deal with CO2, you want to open, close, anything, any maintenance, anything, you'll have to isolate it. So you have got it. Now, this part, pilot cylinders are either nitrogen or CO2. When you release it, that pressure which is released in pipeline opens up remaining valves of the CO2 cylinders. And then the gas is released. When the gas is released, there is another problem that CO2 will be at extremely cold temperature and may form dry ice. Dry ice, if it is formed on the tips of the nozzles where you are releasing the gas, there is a risk of static electricity buildup and a spark. Now, question is, if something is on fire, it doesn't make a difference if there is a spark. You don't release CO2 in potentially explosive atmosphere for this reason. You release it only in fire. Now, the next part comes. If you use the CO2, you have to keep compartment sealed. Okay, this compartment sealing is there for long hours, 24 hours, 48 hours, depending on fire, to ensure that everything is extinguished. Next is entry into space. After using CO2 is done using breathing apparatus. Why? Because there is CO2. You can't start ventilation first. First, you have to send a team to go inside and check whether fire is extinguished completely. Only after they say everything is extinguished properly, then the ventilation will start to remove that CO2 which is there in the compartment. Now, if it cargo fire is there, okay, and I use the CO2, I go and check it out, take care, or I can keep it sealed till I reach port. Okay, I can keep sealed more longer time. But what happens in machinery space? Machinery space, you can't keep it sealed long time because then your engine is not available. You are at mercy of weather. So that is where there is a problem. And if another problem with CO2 is you carry so much percentage. Now, if you use it in one compartment, you may not have gas left for other compartment if the fire spreads further. So it is a bit dicey how to utilize it. Major reason now the hypermist systems are coming in engine room is this, that after CO2, you are disabled the ship. So this is our problem. Now, generally, we are looking at Now, this small system like this is possible you may see in paint locker, or the other one is galley trunking, exhaust gas trunking. So that is where grease collects, and there it can be operated manually. You have one cylinder kept and you just release it from there, both the places. Now, okay, don't get too much into small systems, but now come to low pressure CO2 system. This is a similar system, but here it's a low pressure. It is in liquid thing inside. You keep it close. Everything is okay. And it's only about 20 bars. Now 20 bars is a lot anyway, okay? But for us, 20 bars is a low pressure for this purpose. Now, this one has got filling pipes and all, because if your quantity goes down, you order it, it is filled up the way we fill up petrol in car. Now, this baffles inside is to prove the movements, because otherwise there will be free surface effect. Relief valves will be there, changeover valves. This is all standard stuff. Alarms to indicate if there is a 2% content of the tanks are gone. That means you need a refill, and so on. Now here is a diagram. Okay. Here, refrigeration unit ensures that whatever is evaporating is again put back. So it ensures that by refrigeration, we can maintain it at 20 bars and so much of volume of CO2. When you release it, okay, the usual stuff will be there. Pressure release valve, venting will be in accommodation, means it is not inside accommodation or machinery space. It's in open atmosphere. Then there will be always changeover valves, because what happens, we don't trust, and especially when these pressure release valves can get choked up with the dry ice. So there are issues like that. Then you have got a standard valve from their control panels and all. And when you release CO2 to cargo holds or engine room. So this is a very simple system. There is only one storage tank insulated, instead of having the bank of cylinders. This is relatively a newer technology comparing to that old ancient one. Then there are various alarms. Okay. All the alarms you have to know. Alarms and limitations of the system. Now, this is earlier also we saw that extraction system, which is connected. That is yesterday what we did, not yesterday, on Saturday. We extract samples, or we are continuous extracting, but we are extracting samples and analyzing the samples away from the spot. Now, we come to the one gas system, CO2 basically, and we switch over now to the steam system. Now, steam systems are not allowed. Once upon a time, we had steam systems. Our tanker, I worked on one tanker cadet ship, Jawaharlal Nehru. So it was single hull. Then those were the days when there was no marpole. Okay, we were lucky ones. Anyway, what happened was there, we had a steam system. We did not have anything like inert gas or the crude oil washing, nothing. It was all straightforward stuff. So even our chipping hammers were made up of brass. And our Captain Patankar was very particular. He had given us instruction only brass nails to be used on shoes. Because those days, again, the concept of safety shoes, we had not heard. There were no rubber sole, non-skid sole, nothing. So that time I have seen. But today the steam is not permitted. Okay. So don't bother. That part we don't have to do. Foam systems. Again, we have got three types of foam system: low expansion, medium expansion, and high expansion. Low expansion system, if you find anywhere, you will find it in engine room, if at all you find it anywhere. It goes, see, the low expansion foam earlier was just mixing of two chemicals and the foam was produced by chemical reaction. Later on, we started getting the different types of chemicals and we also started mixing air. So it is possible to get a low expansion foam, which can be used in engine room, but I personally don't think you're going to see low expansion anywhere. Then you have got medium expansion and high expansion. Normally we deal with medium expansion on oil tankers, chemical tankers. The rates, various rates are there. You should know a little bit about them. Certain important things you should know. You should be able to deliver 1250 liters per minute. How do you get these foams? They are much simpler. These foams have got one chemical tank, other one is the water pump discharge, and the chemical tank. They mix up in a mixer. Mixer goes little further and gets mixed with air. Then you will get medium expansion foam. Now that can be anything from 12 times, 20 times. That is medium expansion. Now on tankers, that is required for, remember this part, okay? Tank deck area. Foam is not for fighting accumulation fire. Foam is to fight the cargo fire on tankers. Because what method we use on cargo fires? We have got very straightforward method. We just coat it with foam and cut off oxygen. Little bit cooling effect will be there, but that is not basic purpose. Basic purpose is to make sure there is a sort of artificial blanket preventing oxygen from meeting the fuel. That's it. Now, how do we use the foam? We use foam applicators. That is like little bigger types of guns, which you have seen in the lab. Otherwise, when we restart college, we will keep one or two lectures there so that you can have a look at practically all these things again. And foam is basically just to coat it. So it's not like you throw it in the air and try to expect it to go. No, your intention is one way or the other. It should be coating the deck. Now, there are different challenges. When we tell you about extinguisher, we say hold it, the discharge should be held against a vertical surface and it will drift down and do it. Whereas that is a small amount of discharge. It is possible to control that way. But if you're dealing with the cargo with this sort of a rate, 1250 liters per minute, and you have to handle it for this much, like not less than 30 minutes or not less than, but more or less 30 minutes. And you have got applicators. So what you do is you keep on dumping foam. You keep on dumping foam because no matter what happens, even if the deck has burst open, the oil will be below deck level. So it is possible to dump foam all over. That is what you are supposed to do. And generally these foam applicators, everything are fixed guns. Okay, each one 400 liters per minute minimum, range of 15 meters, and 1250. That is minimum 4 guns you will need. Okay. Then these are the ones which generally you have bigger one or depending on the different shapes and different manufacturers. You will have handle and all to move it. it's like high pressure comes, anything, you will be able to do it by moving the gun in a systematic manner so that just everything is coated. Now you are going to see medium expansion foam, anything like, over this, more closer to 50, 150. If it is acceptable, now 50 will be normally acceptable. 100, depending on foam. The foam has become a complex issue because it is not just simple foam. There is a lot of research, and foam is also used ashore for fighting fires in factories. And in the end, what one is looking for is the foam should be stable. It should not break because there is heat. Ideas foam particles should be clinging to each other so that even if the heat or anything tries to open it, it should not. So there's a lot of science involved in this. Water supply, concentrate. This is that mixer, because the right amount must be mixed, no? You can't be saying, "Arey ज़्यादा है, कम है, थोड़ा माल डाल." You can't do that. So this is automatic process with a small fine tuning adjustments. Network of distribution pipes and method of delivery. Delivery is this gun. Distribution pipes are like this, where the pipe is bringing the foam here. This is parts and parcel you will find in engine room or wherever you have got this tank, foam tank and pump. That is where you will have this. Now, with the foam concentrate is stored in a tank with vents. Vents, why? Because it's a liquid. Any liquid you store on ship will need certain ventilation for many reasons. One is ship is rolling, pitching, it is moving. So you don't want to create unnecessary pressures. So that is one. Also, once it is a tank, it is going to be metallic tank. Or you can't see what is inside. So you have to have a level gauge to tell you how much is the tank. There will be isolating valves because you should be able to isolate the tank in case you are doing some repairs, anything. Then inspection access, because everything must be inspected. So these are the standard things. If you remember all these words, you should be able to rewrite any question by adding up all the masala in answers. Now, it's delivered by foam mixed with water and then it goes out. Okay. Variety of methods, but this is a standard one. Deck monitors and applicators, and then it is dumped on the deck. Okay. This is the typical diagram. This is the diagram you should be able to draw. Water pump. Now, water pump can also be giving water to firemen, okay? But we are using one section here. Now, this flushing line is after use, you need to clean up this system, the foam system. So this flushing line is when you close the tank after use, pump the water, it will go through everything, you discharge it till all water comes clean here. Okay, water must come out clean. That means whole line is cleaned up. That is flushing. Otherwise, foam tank, valves are there. From here, foam pump, it will come to proportional, where both are mixed up in a right proportion. Aerator may be there. Okay, depends on the type of foam. There may be air mixed up here, and then it is delivered. Now, these pipes, the green pipes here, contain foam. That is mixture of, means, it's a foam, not this water directly. Whole thing will be foam. And individual valves are there where you open it up and apply the foam. These ones, here, you have got an option of two, some places. You can use it directly with the water or you can use it with foam. Otherwise, the foam lines are dedicated. But you will also see there are different hydrants available to apply because you also have portable equipment to discharge foam, like the different type of hose which will carry it further, and you deliver it with a fire hose, not fire hose, but something like that. Now, heli deck, you remember we touched it earlier also. Landing facilities different, helicopter facilities, heli deck foam system, because in case in case of any fire after helicopter crashes. So helideck foam systems must be ready. You just coat everything with foam because moment helicopter or anything crashes, they will also have a fuel tank crashing. At least that is what we think fuel tank will crash. So first thing you do is coat it with foam. So even if fuel is leaking, it will not catch fire. So you have to be careful when you are going to use the foam. You can't be blowing it with another jet of water. You have to decide which one you are using. Now, machinery foam system, it's not too common. It's not too common, but it is the same thing. Like if you have to protect compartments like Ro-Ro decks and all, basically closed compartments, then you have got high expansion foam system. Now here you look ratio, see 500 to 1 up to 1000. It is like, something when you're washing your clothes, what sort of a froth you see on top, that type of froth. That is high expansion system. Now, here the difference is, earlier system, what we saw, medium expansion, there is a mixer, it produces foam, the foam is carried and everything perfectly fine. Here, very specifically, to create this sort of a foam, you definitely need air. It has to be mixed with air. So, these are the foam generators. What happens is there is a net, one side, there will be a net which will create the foam. Fan is blowing the air. So air must get mixed with the solution which comes. Water supply plus foam concentrate is mixed up. Like soap water bubbles. We mix up first. Similarly, and then we blow. Foo, foo, like when we play with small children, then bubbles are made. Same process. But it is continuous. The foam is different, so it makes a bigger high expansion foam. Now there are two methods here. One is this part is placed in a place where you are protecting it. Means suppose this room. I need to protect this room. I have this foam fixed inside. So then what I need is, I need only a connection for water mixed with the solution, foam solution, concentrate. And rest of the job is done here because the foam will be produced in this room. This is one type of system. Other one is you produce foam and deliver it through ducting. Ducting is a big thing. Earlier, what we saw, medium expansion foam delivered through pipeline. But here, you will be delivering it through ducting. Here, something here, the picture is giving a little bit idea somewhere. This is how it will be delivered, foam. Because it is coming in duct, like AC ducts. Now, here what happens, if it is ducting system, if I want to put it in this room, I need to release the trapped air here. So the ventilation must be open so that the foam fills up first, then I close the ventilation. So I have to allow this inside air to escape. That is if the foam is produced outside. If the foam is produced here, because the generator is fixed here, in that case, I keep all the ventilation, everything closed. The foam generator is going to use air which is already inside. It's not going to replace something from outside. It's just going to make foam and fill up the whole place. So these are the two different systems which we will be dealing. And the last part, low expansion, like I told you. 1 minute, we will not be able to go more. Okay, this is actually going little excessively technical now. So okay, we stop here. Now, anybody, any doubts, put it on the chat. I will unmute all of you.
Bye, sir.
Bye, sir.
So anybody with doubts?
No, sir.
Anybody? No?
Sir.
I will stop recording
Bye,
then.
sir.
Bye.